Hello and welcome to the class. Today I am going to cover arithmetic progression. What is arithmetic progression? How we can utilize the arithmetic progression nth term and sum of nth term formula. So sequence is called an arithmetic progression if the difference of a term and the previous term is always constant. So an plus 1 is the succeeding term and an is the preceding term. If the difference of these two is always constant, we can say this is an example of arithmetic progression. So for arithmetic progression, how we can find the nth term? Tn is equals to, which represent the nth term, is equals to a plus n minus 1 into d. So a stands for first term, d is the common difference. So if I write like 1, 4, 7, 10 like this. So if you see the difference between succeeding and preceding term is constant, then we can say this is a arithmetic progression. So for this, if you have to find out Tn, what will be the nth term, then Tn is equals to a is first term, which is 1 in this case, n is n, and d is the common difference, which is going to be 3. We have to open the bracket, 1 into 3n minus 3, 3n, 1 minus 3, these two are the like term, minus 2. So this is our nth term. If they ask for what will be the 50th term, we can just simply put the value of n is equals to 50, 50 into 3, 150, 150 minus 2, 148 will be answer. So like this way, we can identify and we can check whether it is with what kind of arithmetic progression, and we can implement the formula. Okay, so let's do some question. If you see this question, Tn denotes the nth term of the series 2 plus 3 plus 6 plus 11 plus 18. Then what will be T50, 50th term, and options are 49 square minus 1, 49 square, 50 square plus 1, 49 square plus 2. So we have to check first whether we can use the formula of arithmetic progression or not, and if we can use it, how we can achieve the answer. So first thing, if you see, this is simply, if you check, is 2 plus 3 plus 6 plus 11 like this. If you see, the difference is not constant. So in this scenario, if I'll say, okay, difference is here, like if you see 1, but here it is 3 and here it is 5. So it is not constant. So we have to think like how we can break this one in order to achieve the below answer. Okay. So what we can see here, like if I say 2 plus 0, okay, plus, I'm just taking this one. This is like 3, so I can write here 2 plus 1 is 3. Now 2 plus, if I write here 2, it is going to be 4. It's not going to be 6, right? So if I do the square here, there will be no change. And if I will do a square here, 2 square is 4, 4 plus 2 going to be 6. Now next term, suppose 2 plus 3 square, 2 plus 4 square. Let's check it. 3 square 9, 9 plus 2 11, 4 square 16 plus 2 18. So now we are getting the values. So this is what simply like 2 is with every term, and then there is 0, 1 square, 2 square, 3 square, 4 square, like this. How we can find the nth term? So this is what, if I suppose pattern, we have to identify this one. So we know Tn is equals to, if I have to write here, a plus n minus 1 into d, where a is 0 in this case, I am going to put here 0, n minus 1 into d. D is common difference, which is going to be 1 in each case. So n minus 1 is the nth term. So I can write here Tn is equals to, first will be 2. This 2 is going to be same because it is coming with, now n minus 1, when we identified the pattern, it was n minus 1, and then there is a word square. Now the question is, what will be the 50th term? I have to put the value n is equals to 50, which is going to be 50 minus 1 whole square, and 2 plus 51, 50 minus 1 is 49 square. So in this case, we can write our answer is D. Okay. So like this way, we have to identify or break the term, and then we can find the answer. Now moving to the next one, sum of nth term. So sum of nth term, what we can do it, the formula is n upon 2, 2a plus n minus 1 into d. This is one formula where a is first term and d is the common difference. Also, we know Tn is equals to a plus n minus 1 into d. What we'll do, we'll break this 2a into a plus a. And now if you'll see, this is nothing but what Tn. So I'm going to write here, this is what Tn. So now my second formula will be, first formula is Sn is equals to n upon 2, 2a plus n minus 1 into d. Another formula will be Sn is equals to n upon 2, first term plus last term. So this is the sum of the nth term. So suppose if we have a question like 1, 3, 5, 7, like this is what arithmetic progression, right? If I will say find the S20th, S20. So 20 till 20th term we have to sum and we have to find the answer. So since we know the formula, we can use it. If the nth term is given, like last term is given, then we can identify, or we can directly simply put it the formula. In this case, n is going to be 20, a is going to be 1, d is going to be 2. Difference, if you see, it is what 2, it is what 2, and yeah. So we have all the things. So what we'll do, n upon 2, that means 20 upon 2, 2 into 1 plus 20 minus 1 into d is what 2. So in this case 20 upon 2 is 10, then 2 plus 1, 2 into 1 is 2, 20 minus 1 is 90, 90 into 2 is 38, 38 plus 2 is 40, 40 into 10 is 400. So our answer is 4. So sum of 20th term is 400. Okay, so like this way we can find the sum of nth term. Moving to the question, in an AP, if SP, that means sum of the pth term is equals to q, sum of the qth term is equals to p, and SR denotes the sum of the first R term, then what will be the value of sum of p plus qth term? Okay, p plus qth term. So that means they are simply saying, if it is what C, A is our, consider A is our first term, okay, in each case, right? Because sequence is same, only the pth and qth term are coming, and d is the common difference. I am writing here CD, that means the common difference. So the question is S, P plus Q if we have to identify, that means P plus Q, formula is n upon 2, 2a plus P plus Q minus 1 into d, right? Now we have to find out the unknowns, like a, what is a in this case, what is d in this case. If we'll know the value of these, we can simply put it and we can find the value of this. Now for this we have two things given, SP and SQ. So SP is given like sum of pth term. I will write here p upon 2, 2a, p minus 1 into d, and sum of pth term is how much it is given, q. So q is equals to p upon 2, 2a plus p minus 1 into d. This 2 will go here. I can write it 2q is equals to p, or 2a, I can write here 2ap plus p square minus p into d. I just open the bracket for the first case. This is our first case, okay. Now second case is also given. So what is second case? Second case is SQ. So I am going to write SQ is equals to SQ upon 2, 2a plus q minus 1 into d. Now SQ is how much, p. So p, 2p, I am just writing in shortcut like 2p is equals to q, 2a plus q minus 1 into d. Now I will open the bracket like this, similarly what I did it for the first one. 2p is equals to 2aq plus q square minus q into d. This is our second. Okay, subtract first from the second or second from the first, anything we can do it. Okay, okay, so let's subtract 2 minus 1. So next I am going to take it. Okay, so 2 minus 1, if I will do it, that means 2 minus 1. Okay, so 2 minus 1, go to the previous page, check 2p minus 2q. So I am going to write 2p minus 2q is equals to whole 2aq plus q square minus d. So I am going to write here 2aq plus q square minus q into d. Okay, that is done, minus 2ap, okay, minus p square minus p into d. This is our, okay, take 2 is common, I will take 2 as a common, so p minus q. If you see, let's do some arrangement, this term and this term, okay, so I will write a 2aq minus 2ap plus d, I will take it from both of these terms, and I will write here q square minus q plus, oh my bad, minus p square minus plus p. Okay, so arrangement is done. Now I have to take, okay, take minus common from here. So what I can write here, q minus p, just I have to interchange the sign. Here if you see 2a is common, what I can write here, q minus p, correct? So q minus p. Now if you'll see here, we have to do some arrangement, square and square term will come along, so q square minus p square, one term, and here is like if I will take minus common, so it will be q minus p, this is another term. Okay, 2q minus p is equals to 2a q minus p. Now if you'll see here, a square minus b square is a plus b and a minus b. I'm going to write one more line, q minus p into q plus p minus q minus p. Okay, now if we'll see everywhere q minus p and q minus p, we can take and cancel it. So minus 2 is equals to, it will be 2a plus d p plus q minus 1. Okay, and if we'll see this is what, 2a plus d p plus q minus 1, 2a plus p plus q minus 1 into d. Oh my bad, yeah, like that. Okay, so this is nothing but this value which I am going to get it minus 2, right, minus 2. So I have to simply substitute it, and p plus q into 2 minus 2, this and this got cancelled, my answer will be p plus q, and then there is a minus sign, so b is the answer. So like this way we can do, there are multiple ways to do the questions. Okay, I just demonstrated one way, there are different ways we can solve it by shortcut as well. So this is how we can solve arithmetic progression questions. I will come up with another examples in another session where I will cover the geometric session and other geometric progression and other. Okay, thank you so much for watching this video.